Okay, this time I'm going to discuss about factoring perfect square trinomial. Okay, last time we had discussed already how to factor general trinomial. Now let's have a short review. Okay, we're going to factor n squared plus 16n plus 64. Okay, so again, when you factor this, expected that you have two binomial factors. So you factor first the first term, n squared, that would be 2n, and then you factor 64, such that you can get the middle term 16n. Okay, so 64, actually there are many factors for 64. 64 times 1, negative 64 times negative 1, 8 times 8, and negative 8, negative 8. Actually, many more. Okay, here, we're going to use negative because here, as you can see, the signs for the second and third term are both positive. So, we're going to omit the chances of using negative factors. So, actually, aside from these two choices remaining, there are many actually. So, you list all of that and you can try, and you cannot get the correct factors if you're going to try other numbers. So here 64 and 1, when you add them, just the tip I introduced you last time, that is equal to 65. But okay, notice that the middle term, the numerical coefficient of middle term is 16. So very clear that this cannot be used. So we could use 8. So plus 8 and plus 8. Okay, you can check your answer. 8 times n, that's 8n. 8 times n again, 8n. And then you add 8n plus 8n, that is 16n. Okay, we get the correct middle term. Okay, so as you can see, you have the same binomial factors. So we can express that into in the power to the power of 2. Okay, so you have your n plus 8 quantity squared. Okay? Okay. This is case number 1. Okay. I'm going to give you another case. Okay. Or another example. Okay. You have your 4x squared plus 4x plus 1. Okay. Okay, for this class, from the previous topic or example that I gave you when we have our lesson about factoring general trinomial, I didn't give a first term whose numerical coefficient is not a 1 or not a prime number. So here, as you can see, 4 is not a prime. So we're going to consider that we'll not factor that first. Okay, so we'll factor first the last term, which is 1, since 1 has only one pair of factors, which is 1 and 1 itself. So again, so when you encounter trinomials wherein the first or the last term you have a not prime factors, so or it might be the first term is not a prime factor, I mean prime term, or you have there not a prime number, specifically the numerical coefficient. So better you start with the other term, which is either first or last term. So here, the last term is this not prime number. 1 is not a prime number, but it's obvious that the factors are only 1 or 1 and 1 or 1 is only 1. Okay? So you have here so factor 1. So positive 1. Do not consider negative since you are given here positive or plus. Okay, now let's proceed with 4x squared. So x squared, when you factor that, that could be x. But how about 4? So 4, again, do not consider negative factors since you have no negative there. No negative sign. So it could be 4 times 1 or could be 2 times 2. Okay? So we're going to check. So you can have here 4x and 1x or just x. So let's check. 1 times x, that is x. 4x times 1, that is 4x. So you add x plus 4x. That is 5x. Oh, we didn't get the correct middle term. So meaning, we cannot consider this. How about 2 and 2? Okay, let's try. Okay, you have their partner of x, which is 2. So you have your 2x and another 2x. So multiply 1 times 2x, that would be 2x. Okay. Another one, 2x times 1, that is 2x also. And then we're going to add the result of the product for the inner and outer terms. So you have there 2x added another 2x, that is 4x. Okay, we get the middle term, 4x. So since we have here the same binomial factors, so you express that to the power of 2. That would be the quantity of 2x plus 1 squared. Okay, based on the example 1 and 2, okay, notice that their factors are expressed to the power of 2. Okay. So class, as I said earlier, our topic for this day is about factoring perfect square trinomial. So this is a special trinomial. So the given 1 and 2 examples or trinomial are called perfect square trinomial. So as you can see, their factors are expressed to the power of 2. That is why they are called perfect square trinomial. Okay, but how are you going to know that a given trinomial is a perfect square? Okay, take a look at this. Okay, you just check the first term, check the first term, and second term. They must be both perfect squares. So, it's not second term. What I mean is last term or the third term. Okay, to be specific, third term or the last term. Okay, so here n squared, let's check. Okay, very clear. N squared is a perfect square. And then 64 also is also a perfect square, which is 8 squared. Okay, does not stop there. on checking whether the trinomial is a perfect square or not. Okay. The second is when you get the square root or say for example, let's express and square the first and the third term into the power of 2. So that is n squared, and then 64 is 8 squared. And get the base or the square root of each term. So for the first term, the base or the square root is n. Well, the third term, the square root or the base here is 8. And then, you multiply it by 2. So, 8 times 2, 16 times n, that is 16n. Okay, we got here 16n. So, meaning to say, this trinomial is perfectly, of course, perfect square trinomial. So, that is how to check. Again, you check if the first and the third term or last term are perfect squares. And then, you multiply the two square roots of the first and the third, or the base, when the first and third term are expressed to the power of 2. And multiply it by 2. If you get the middle term, that means to say that is perfect square trinomial. Okay, how about the second example? Let's check. Okay, the first term, that is 4x squared. Okay, that express it into the base of 2 is 2x quantity squared. So, very obvious, 4x squared is a perfect square. Okay, the last term or the third term, 1. 1 can be expressed to 1 squared. So, 1 is a perfect square. Okay, next. Let's check. So, get the base, 2x times 1, and then you multiply it by 2. So, 2x times 1 times 2. 2x times 1 times 2, that is 4x. Okay, so that's the middle term. So, this is also a perfect square trinomial. Okay, I'm going to give you a trinomial that is not a perfect square so that you can compare or you can differentiate what is a perfect or not perfect square trinomial. Okay, let's have example here. Okay, not perfect square trinomial. Okay, you have here x squared plus 5x plus 4. Okay, let's do that. Expected, you have two binomial factors. So for first term, it's x. For the 4, okay, I'm just going to give you the correct answer directly. So that's 4 plus 1. So after doing the turn error, so you check that in your notebook. 4 times x, 4x. X times 1, x. So when you add 4x plus x, that's actually 5x. So these factors are correct. Okay? So it is obvious that's not a perfect square because you didn't come up with an expression that is expressed to the power of 2. Okay, let's do the test. Okay, first term, x squared. Okay, this is a perfect square. Check. Okay, last term, 4. That is 2 squared. That's a perfect square. Check. Okay, and then you get their base or the square root for each term. So that would be x times this 2 times 2. You always multiply it by 2. So x times 2, 2x times 2, that is 4x. Since the result is 4x, not 5x, so meaning this is clear that x squared plus 5x plus 4 is not a perfect square. So, you can check, no? There are two ways to check. You factor directly, or you can do this test. You test if the first and the last term are both perfect squares, and then you multiply the two terms, the two square roots of each term or two base, and then you multiply it by 2. So when you get the correct middle term on the given trinomial, meaning it's a perfect square trinomial. Okay? Okay. Now, so in general, you have here the pattern, or shall we say the rules for perfect square trinomial, PST. So you have your a squared plus 2ab plus b squared. So it's very clear. So the factors are a plus b and then a plus b, or express that into to the power of 2, a plus b quantity squared. How about if you have minus? So the same pattern, that would be a subtracted by b and a subtracted by b. That would be the quantity of a minus b squared. Okay? So that's very clear. So the first and the last term are perfect squares. You multiply the base of, or the square root of each term, the first and the last term. So you have your a and the b. You multiply it and then multiply it by 2. So that is the perfect square trinomial. So here, when you have minus, so expected that here in the binomial factors, the operation is minus or subtraction. Okay, let's have more examples. Let's have here number 1, x squared minus 14xy plus 49y squared. Okay, let's check first if this is a perfect square trinomial. Okay, first term, that is x squared. Okay, that's very clear. This is perfect square. The last term, that is 49y squared. Express that to the power of 2. So that would be 7y quantity squared. Okay? Or class, let's express that minus 14xy plus the quantity of 7y squared. Okay, so you have your x squared, but it's very clear by using the pattern above. Minus 2, okay, the base for first term, you have your x. And then the base for the the last term, that's 7y. So plus 7 square of 7y. So this is very clear since we express this into this pattern, the PST or perfect square trinomial. So this is clear. That's x squared minus 14xy plus 49y squared is a perfect square trinomial. Okay, so that's easy. So get the factor. So we have shown that this is perfect square. Okay, so just pick up the base x and then minus. You have here 7y. That's quantity squared. Okay. But class, if you get confused, you can also use the trial and error process that we use in factoring general trinomials. You get the same answer. Okay, let's have another example. Three x squared minus 18xy plus 27y squared. Okay. Okay, so as you observe, have your first term, 3. Obvious, that's not a perfect square. Okay, third term, 27, not also a perfect square. But not this, 3, 18, 27. What they have? They have GCMF, which is clearly 3. Okay? Apply the factoring of polynomials using GCMF. So you have your 3. You divide each term by 3. 3x squared over or divided by 3 minus 18xy divided by 3 plus 27y squared divided by 3. Okay, simplify. 3 divided by 3, that's 1. Then you have your x squared. So that's 1x squared or x squared. Minus 18 divided by 3, that is 6. Then you have your xy. Plus 27 divided by 3, that's 9. Y squared. Okay. Okay. Let's check if this is a perfect square trinomial so that we could apply the tip on factoring the PST or perfect square trinomial. Okay, 3. So you expected that you have 2 binomial factors. Okay, first term is a perfect square. 9 is a perfect square and y squared also. Okay, so let's check if we get 6xy. Okay, that would be x squared minus 6xy. You express 9y squared into base 2. 3y quantity squared. Okay. Apply the pattern. So you have here x squared minus 2. And then base x base 3y plus quantity of 3y squared. Okay, that's very obvious. So 2 times x times 3y, that is 6xy. So meaning this given this 6x squared minus 6xy plus 9y squared is a perfect square. So now the factors would be, it's very easy since this is a perfect square trinomial. X plus, you just get the base of first and third. If that is a PST, okay, plus 3y quantity squared. Okay, let's have third example. Okay, you observe 75t cubed plus 30t squared plus 3t. First term, that is not a perfect square. Third term, 3t. That's not also a perfect square. But notice, common t. One factor t. 75, 33, they have also common. factor. So the same with number 2 example, meaning they have GCMF. So that would be 3t. Okay, and then you divide each term by 3t. 75t cubed over 3t plus 30t squared divided by 3t plus 3t divided by 3t. Okay. So you have 3t. 75 divided by 3, that is 25. T cubed divided t, that's t squared. And then 30 divided 3, that's 10. T squared divided t, that's t. And then plus 3t divided by 3t is 1. Okay. Let's clear this one. Okay. Next. So, let's check here if this 25t squared plus 10t plus 1 is a perfect square trinomial. So, check if the first term is a perfect square, 25t squared. Okay, that is a perfect square. 1 also a perfect square. Okay, it's clear. Express each term to the power of 2. So that would be 5t quantity squared for 25t squared. And then plus square of 1, that is 1 squared. Okay, you can do this directly, class. So you have your, again, when you have PST times 2. So just multiply the base or the square root of each term. 5t times 1. Okay. So, as you observe, 2 times 5t times 1 is 10t. So, clear that this is a perfect square trinomial. So, since it's perfect square trinomial, you do like this directly. Get the base of first term, that's 5t. And then base for here, 1. Okay. Again, when you say base, that must be expressed to the power of 2. Okay? That's it. Okay. Again, reminder, you can check if your answers or solution is correct by multiplying or by getting the product. And you get the trinomial or the given trinomial. Okay, that's all for the factoring polynomials. For more questions, or you can ask me directly. Okay, you can comment here on this video. And don't forget to subscribe. Okay, stay up for more video lessons. God bless you.